This is a so previously what we defined was we defined the Biot-Savart's law. So the Biot-Savart's law, what it said was that if I'm having a conductor through which the current is passing is I, and if I'm taking an infinitely small length dl, and if I'm having the current flowing through it di, if I'm finding the magnetic field intensity at a point, suppose it is P, then it can be easily said that, and the direction is in this way, and the magnetic field intensity dH or H was given in that case as H is equal to the integral of IDL into AR divided by 4 pi into r square, which was the distance between the point. So this was the integration equation of the Biot-Savart's law, and this was the magnetic field intensity. And now if I am having a closed path through which a current is flowing, and if I am starting from the point and if I am coming back to the same point, then it is said that the integration of the magnetic field intensity over a closed path will give me my current flowing through that path, which is known as the Ampere Circuital law. So this video was about the derivation of the Ampere Circuital law. Also, this gives what is known as the Maxwell's third equation for electrostatics or static electricity and magnetism. So if I'm having my I is equal to H dot dl, which is going over a closed path, then if I'm applying Stokes theorem to this, Stokes theorem for vector fields to this, what I will get is I'm having a surface integral, and then del cross H dot ds will be equal to surface integral of H dot dl, which is equal to I. So my I is equal to surface integral of J dot ds, which is from my equation of current density. So it can be easily said that del cross H is equal to the current density J, which is the third of Maxwell's equations for static fields. So this is essentially Ampere Circuital law in a different form. So the Ampere Circuital law was this, and whatever we have found here, the Maxwell's the third equation is essentially the Ampere Circuital law. And what this says is that unlike the electrical field, which had the equation of the del cross E equal to 0, if I am correct, for the second Maxwell's equation was something like the electric field, whatever the electricity which is entering was same to leaving. So electrical field was electrostatic fields are conservative, but at the same time you can say that the magnetostatic fields are not conservative. So this is given by the third Maxwell's equation, or this is shown by the third Maxwell's equation. And this was the derivation of the Ampere Circuital law, and the derivation of the Ampere Circuital law was found out from the equations of the Biot-Savart's law.